Good morning. This video is going to be 15 minutes. If I had to add another one for chapter 2 review, I will. It'll just be called part 1. So I'm going to go over some of the basic ones. If we look at question 1, I shouldn't say basic ones. I'm going to go over the ones that are very repetitive throughout the process. So you could do the other problems without any issues. What's the domain? You can see this function. There's no x values. It wouldn't work. It goes from negative infinity to infinity. It's going to keep going in the left direction and the right direction. The range would also be the same. Question 2. It says a cube root of 2m minus 1. So again, we use inverse operations to solve any equations by isolating them. So here, the inverse of a cube root is the third power. So you get 2m minus 1 equals negative 27. And then the rest you just solve. Okay? Any questions on that, please message me. We're going to go on to question 3 now. All right, what's the end behavior of the graph? So it's a fourth degree polynomial, so you should know it's an even function. You could use your graphing calculator, but you should not need to. Okay, it's a fourth degree, so it's going to start and end in the same direction. Since it's negative, that means it's ending in a negative direction. It also means there's 3 turning points, 1, 2, 3, because it's a fourth degree. You just take one away. Okay. So you can see as you go out to, still working this to make sure it comes out. All right. So as you go out to negative infinity, f of x is going to approach negative infinity. So you know that's not the answer. And this isn't, because as you approach positive infinity, it's also dropping to negative infinity. So your answers are C. Okay. Question 4, number of turning points. If it's a third degree, the most it could have is 2. Okay. 1 less than the degree of the polynomial. All right, this one asks which binomial is not a factor of that polynomial. We're going to use synthetic division. First, x minus 5. So I'm going to use 5 for synthetic division. And I write them all out. If there's missing a term, make sure you write 0. Drop down to 1. Hopefully you remember synthetic division. You write out all the coefficients, and then you would solve for x there. So x minus 5 is 0. You would add 5. That's 5. So 1 times 5 is 5. Then you add them when they're there. So that's 10. 10 times 5 is 50. And we add those. That's negative 43. And then when we multiply that, you get negative 215. And as you can see, the remainder is not 0. So it is not a factor. So you would keep working them out. All right, so now I'm going to try to see if x minus 2 is a factor. So again, bring down the 1. Okay, 1 times 2 is 2. You add them. 7 times 2 is 14. You add them, you get 7. 7 times 2 is 14. Negative 15 times 2 is negative 30. And the remainder here is 0. So therefore, x minus 2 is a factor of that polynomial. Any questions, please message me. What are the asymptotes for the graph of g of x equals 6x minus 1 over 3x plus 4? So the vertical asymptote's the denominator. So you said we cannot equal 0. But to find the vertical asymptote, you would have to do that. So subtract 4. So the vertical asymptote's x equals negative 4. So you know that's not the answer. It could be any one of those 3. But since the degrees on the numerator and denominator are the same, we divide the coefficients to find the horizontal asymptote, which is 6 divided by 3, which is 2. So y equals 2. So this is the answer here, and we can move on. Next one's number 8 that I'm going to go over. What's the domain of the function? You can see here it's everything except for 0. So when we write this in interval notation, we don't want to use brackets because it doesn't equal 0. So we would say negative infinity to 0, but not including 0. And then or from 0, not including 0, to infinity. Now on to question 9. Find the zeros. You could do this using your calculator or you could factor it, but I will show you using the calculator. The first thing you should do is go to y equals and type it in. And then graph it. And you can see that there's 3 zeros. I'm going to first go to the table because if they're there and they're integers, then we are done. And we got all 3 because the most we could have is 3. So we could see here that it's -2, 0, and 2. The next question, it's going to talk about which functions has a removable discontinuity. So those are the wholes. Those are one that's going to cancel out. We know that number 1 is a polynomial, so that is definitely not going to be an answer. This one factors, but there's not going to cross the x out. So this would be 2 vertical asymptotes. And as is this is the only one. You can see that those 2 there would cross out. So at x equals 2, it's a removable discontinuity, which means the whole at that point, which, they factor this one for you, so it made it easier. Number 11, find the inverse. So first step to find the inverse is switch x and y, and then solve for y. So we're going to add 4 and then divide by 2. So y equals x plus 4 over 2. We would write the inverse as x plus 4 over 2, which is A. All right, question 12. What is the horizontal asymptote? Again, the degrees are the same. You can graph it to see as well, but since the degrees are the same, the horizontal asymptote is going to be by dividing the coefficients. And if I graph this one, you can see it as well by going to y equals, clear the previous one out, and do 3. Make sure you put the numerator in parentheses and as well as the denominator, divided by 4x squared. Some of you guys aren't going to do the denominator, but then it's going to divide by 4 and then multiply by x squared. So if we graph this, you may not be able to see exactly where it is on the graph. It may look like, oh, it's 1, but it's not 1. Okay. So we go to the table, and as we go to infinity or negative infinity, doesn't matter. You're going to see that it's approaching 0.75, which is 3/4. Okay. So that's another way to do that if you need to. Next one, the end behavior. Again, odd degree starts and ends in opposite directions. Since it's a negative leading coefficient, it's going to end by going down 2 turning points. So that's how a graph approximately would look to be able to give us. So a limit as x of f of x, as x goes out to negative infinity, which is this way, it's going to positive infinity. Okay. The limit of f of x as x goes to infinity is going down to negative infinity. So we can see our answers are right here. Number 14, our synthetic division problem. So we're going to go ahead and write, we would solve for x plus 1, so it's going to be -1 in the box, then 1, -2, -4, 1, and 2. Okay. Bring down the 1. 1 times -1 is -1. We add those, you get -3. -3 times -1 is +3. We add those, you get -1. -1 times -1 is 1. You get 2. 2 times -2 is -2. No remainder. We would write it 1 degree less, so it's x to the third minus 3x squared minus x plus 2. Okay, now on this problem, when you're solving a rational equation, first thing you gotta do is factor. So factor everything. So I factored this here. And then you want to get the least common denominator, which is x minus 8 and x plus 4. So this part, I have to multiply the top and bottom by x plus 4. This one, I got to multiply the top and bottom by x minus 8. And then we have to find out where it's undefined. So x can equal 8. That would give the denominator 0, or x cannot equal negative 4. Okay. And then you would just multiply by the denominator, and that would leave us with negative 3x minus 2 times x plus 4 equals 3 times x minus 8. And then you would go ahead and distribute the negative 2 and distribute the 3. And then you would solve it to negative 5x minus 8 by combining those terms. And then we're going to subtract 3x and then add 8 to the other side. And you're going to get negative 8x equals negative 16. You divide by negative 8, x equals 2. And we can check it can equal 2. So our answer is 2. All right, solving this question. This one's fairly easy. Anytime you have radicals, you want to isolate one of the radicals and then square it. But since there's radical on both sides and they're both isolated, you would square both sides and then you would get this. And then that's a very easy question to solve. So go ahead and finish that after you square both sides. All right, again, some of them are repeated. So I'm going to go to question 22 now. It says physics. The height h in feet of the ball thrown in the air after t seconds is given by h of t equals negative 16t squared plus 35t plus 6. Use synthetic division to find after 0.5 seconds. So 0.5, that's negative 16, 35, and 6. So negative 16 times 0.5 is negative 8. So you get 27 times 0.5 is 13.5. So your answer is going to be 19.5 feet. Okay, question 23 now. Find the remainder when it's divided by x minus 1. Is it a factor? So x minus 1, so we would solve it. X minus 1 equals 0. So again, we already went over some synthetic division problems. So 1 goes here. And then you write 2, 6, 3, negative 1. It is a factor if the remainder is 0. So let's check. We've already done a numerous amount of synthetic division. 2 times 1, add there, 8 times 1. So you can see here that it is not a factor, and the remainder is 10. All right, says for a period of x days, find the count modeled by f of x, x minus 3 minus x squared minus, when was the balance 60? So the good way to do this problem is to type it into the calculator and graph it. Okay, so I typed it into the calculator, and then we're going to find out when the balance was 60, how many days. So I'm just going to go to the table and find out when the balance was 60. 5, 9, or 10. Let's look at 10. Nope, it's a lot more than that at 10. So it says 60 at day 5. What are the vertical asymptotes of f of x? Well, you factor the numerator and denominator. It's important to factor the numerator too, just in case it is not a whole, which means a removable discontinuity. So you can see here that nothing crossed out, so there is not a removable discontinuity. Those are infinite discontinuities. So it's going to be at 3 and negative 3, which is there. The concentration of medicine is modeled by that equation. What is the horizontal? Again, if the degree is larger on the bottom than the numerator, then it's y equals 0 is the horizontal asymptote. All right, so that was part 1 of chapter 2 review. I will post another video for part 2.